Question number 1. Yeah. Question number 1. A die is rolled. Let E be the event. Die shows 4 and F be the event. Die shows even number. Are E and F mutually exclusive? Can you do that?
Okay. Yeah. No.
Why? I mean, I want the reason.
Because it won't be a null set.
Yeah. So you will get 4 as the common intersection. It is not a null set, so it is not mutually exclusive. So E and F are not mutually exclusive. So question number 3, an experiment involves rolling a pair of dice. Okay, pair of dice means 2 dice, and recording the number that comes up. Okay, describe the following events. The sum is greater than 8, comma B, A. Okay, A is the sum is greater. Okay, part A is sum is greater than 8. Can you describe the following events? If you are throwing a pair of dice,
Okay.
the sum should be greater than 8 means what you should get the sum will be either 9 or 10 or 11 and 12. Okay,
Okay.
more than 12 it doesn't exist because the
No. 6 plus 6.
is 12. Yeah, very good. So you just have to find what are the, I mean, what are the possibilities that will make this thing equal. Okay, so that will match this 9, 10, 11, 12. Okay, if you sum up you'll get either 9, 10, 11 and 12. Okay, can you find that?
Okay. I should write down.
Yep.
I'll write down my notebook and read it out now.
Yeah, you can read out also, no problem.
A is
Yeah,
3 comma 6,
yeah, 3 comma 6.
4 comma 5,
Yes,
4 comma 6, 4 comma 6, 5 comma 4, 5 comma 5, 5 comma 6, 6 comma 6 comma 6, 6 comma 5, 6 comma 4, 6 comma 3.
yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 even. So this is how you have to describe. And in part B they are asking 2 occurs on either die. Okay, 2 occurs on either die.
1 comma 2, 2 comma 2, 3 comma 2, 4 comma 2,
So 6.
5 comma 2, 6 comma 2, and
So there are
2
6.
comma 3 comma 1. Sorry, 2 comma 1, 2 comma 2, like.
You should not repeat this. Okay, already you have written 2 comma 2. Okay, so
Okay. So,
repeat the same thing. So it should be 5 events. Okay, 2 comma 3, 2 comma 4, 2 comma 2 comma 6. 5 events here. Okay, right? So total 11 events. In part C, the sum is at least 7 and a multiple of 3. At least 7 means it is more than 7 or more than or equal to 7. So that is either it can be 7, 8, 9, 10, 11 and 12. Okay, and it is a multiple of 3. So what are the numbers that are multiple of 3 here in this?
3 and 6.
What? But they said it is at least 7. Okay, at least 7 means Here, it is about the sum. The sum should be multiple of 3.
Oh, okay. Okay. 3, comma 6.
Yeah, so that is 9.
6,
Okay.
6, comma 3.
Hmm.
6, comma 6. 4, comma 5. 5, comma 4.
That's it, right? So 5 events. So these are the favorable events for this question. So number 5. So which pair of these events are mutually exclusive? Question number 5. Three coins are tossed. Describe two events which are mutually exclusive.
Okay. Oh, fifth one.
Yeah, three coins are tossed. You have to describe two events which are mutually exclusive from that three coins when you're throwing three coins.
Uh, when written like A and B, sample A, sample space B, like that.
Yeah, I mean you have to tell me what are you have to guess the two events so that if you take intersection of those two events, if you're throwing three coins, then that should be null set. You have to tell the
Uh,
event.
Space A will have 3 heads. Sample space B will have 3 tails.
That's not the sample space. That is events. Okay, so event A is having three heads, and event B is having three tails. Then I mean all the heads and all the tails intersection is null set and they are mutually exclusive. Right. Part two. Which three events which are mutually exclusive? Three events. Okay, not one or two. Three events which are mutually exclusive and exhaustive. Okay, exhaustive means if you take union, you should get all the things. Okay.
Okay. Uh, the same event A has all heads, 3 heads.
But they are not exhaustive, right? Exhaustive means that should contain all the possible outcomes. If you take union, that should contain all the possible outcomes of the space means it should contain all 8 outcomes. Okay, if you're throwing 3 coins, you'll get 8 outcomes or 8 possibilities. But if you're taking union, you're getting only 2 possibilities. Okay.
Uh, uh, Event A getting all heads, event B getting all tails, event C getting at least what is this?
One head. Yeah, that is
No,
either one head or
that,
anything will work. Okay, that's right. At least one head. Yeah.
no, it is not.
No, because then there will be intersection. Okay, they are not mutually exclusive then.
Um. Okay, so event A, uh, all heads.
Yeah,
Uh, Event B, only one head. Event getting only one head.
yeah, then there will be like head, tail, 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 head, tail, 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 head. Yeah, so you will get three here, one here. Okay, so what about event C?
Getting only two heads.
Only two heads, then okay, then there is an intersection. Okay, only two tails. Okay. Tail, head, tail, head, tail. Okay, two tails means tail, tail. Two heads are two tails. Two tails, tail, tail, head, tail, tail, head, tail, tail. Yeah, I think it's three, and seven. Okay, I mean, there is one thing like tail, tail, tail is excluded from this. Okay, that is not uh, exclusive. Okay, I mean not exhaustive, because this case is missing from this. Okay,
Yes, sir.
I think if you take yeah, so what I would do is, see, I will tell you like this. So suppose if event A is getting all tails, event B is getting all heads. Okay, event C is not getting all the heads or all the tails, then you will get either six outcomes, right? In that case,
Yes, sir.
not getting all the heads, all the tails. Okay, so you'll get six outcomes there, and this is seven and this is eight. Okay, then you will get other than this and this all the outcomes. Event C is, you can say, not getting all the heads or tails, then you will get six, and those are, if you take intersection, they are mutually exclusive, and if you take union of all the things, that are mutually exhaustive, right?
Yes, sir.
Yeah, you are close, but you have to try a bit hard. This is a tough question. So third one, two events which are not mutually exclusive. Yeah, you can say anything like getting two heads and getting three heads. I mean,
Yes, sir.
getting it one head, getting at least two head. You can say that they are not mutually exclusive. Two events which are mutually exclusive but not exhaustive. So as you said, mutually exclusive means intersection is like head, 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 tail, tail, tail. Their intersection is null, but union is not exhaustive, right? So this is another example. This can also be easily done. Three events which are mutually exclusive but not exhaustive. As you said in the previous case, getting heads in event A, getting tails in event B. I mean, getting heads in event A, getting at least one tail, and C is getting at least one head. So their intersection is null, but I mean here getting two tails, here getting two heads, their intersection is 5, but union does not contain tail, tail, tail events, so they are not exhaustive, right?
Yes, sir.
So question number 7, refer to question 6, state true or false. Okay, you have to refer to question 6. A, B, C are as follows. Getting an even number. A is like getting an even number on the first time, and B is getting an odd number on the first time. C is getting the sum of the numbers on the die less than equal to 5. Okay, A and B are mutually exclusive. Like you have to go for A and B, like getting an even number and getting an odd number. So A and B are mutually exclusive or not?
Yes, sir.
Yeah, they are mutually exclusive. A and B are mutually exclusive and exhaustive.
Yes, sir.
Yes. And A is equal to B complement or B dash.
Yes, sir.
Yes. So there are different arithmetic approach to probability. So first of all, what is probability? Okay, probability is nothing but, so till now we discussed about events and sample space. So probability is nothing but
Likeliness of any event.
all favorable outcomes or the points in the events. Okay, and then total possible outcomes divided by total possible outcomes are total outcomes in the sample space, right? So if I say, if you're throwing a coin once, getting a head, what is the probability of getting head?
50%.
Yeah, or 1 by 2, because even, I mean, favorable outcomes are one head, and total outcomes are sample space, which is head and tail 2. So 1 by 2, or 1 out of 2, is your probability. Okay, percentage probability is 50%. Yeah, and probability is always 0 is less. Probability of any event is less than equal to 1. Okay, it lies between 0 and 1, no matter whatever the probability is, right?
Yeah.
And there are some axiomatic approach. There are some rules like probability of any event should be greater than and equal to 0, and probability of the sample space is 1. Sample space means it contains all the events, so obviously numerator and denominator will have the same number of elements or same number of points, so that if you divide the same thing, you will get 1. So if E and F are mutually exclusive event, then probability of E union F is probability of E plus probability of F. Why? Because E union F is nothing but probability of E plus probability of F minus probability of E intersection F. This is the formula. Probability of E union F is probability of individual event E and probability of individual event F minus probability of E intersection F. Okay, if there is any common thing between that, then that probability. Because if E and F are mutually exclusive, because E intersection F is phi or nothing, so this term will become 0, and this will become probability of E plus probability of F. Okay,
Okay, sir.
now uh, yeah, probability of E union phi is probability of E plus probability of, and probability of null set is always 0, because there is nothing there. Okay, nothing means 0 by sample space is 0 by whatever the sample space number of events, that is always 0.
Yes.
And sum of all the probabilities of a sample space, I mean, all the events in a sample space is 1. Okay,
Okay.
okay, that's all. Some questions. Equally likely outcomes, it is always 1 by n. Equally likely outcomes means, for example, getting an even number, they are like equally likely outcomes, right? Or getting a for example, if you're throwing a die, probability of getting a positive number is always equally likely, right? Because you'll get 1, 2, 3, 4, 5, 6. So each probability is 1 by 6. So yeah, they are equally likely. These are tough questions. Let's solve some questions so that you will have an idea. So which of the following cannot be valid assignment of probabilities for outcomes of the sample space S? Which is omega 1, omega 2, omega 3. Okay. So that which are not not the, what they call, valid assignments for the following events. Okay, for the following outcomes of the sample space. Okay, for the following outcomes of the sample space, so each one is the individual event of the sample space. There are 7. which one is not allotted properly or not allotted for the sample space. So one thing is, if you sum up the events of a sample space, that should be equal to 1, right? So if you have that idea, then you can answer this. So you will go for, you will sum up all the probabilities, and whichever is not equal to 1, then that is not assigned properly. Okay,
Okay, sir.
so which one? Yeah,
Which one, sir? C.
C. Why? Because it is, you're getting more than one for sure, so this is not assigned properly.
Yes. D. Negative is there.
D, how much you are getting?
No, D because negative answer there. Negative minus 0.1 and minus 0.2.
Yeah, you won't get negative values in the probability. Very good. So D is also not assigned properly. Very good. And is there anything else?
Uh, yeah, E uh,
Yeah,
15 by 14, that's not.
yeah. See, if you sum up all the things, this individual thing is greater than 1. If you sum up all the things, that is also greater than 1. This is also not. So what are the things you'll get? 9. Yeah,
C, D, and E.
yeah. A and B are your
Valid.
valid assignments. Okay. Question number 3.
Then a die is thrown, find the probability of following events.
The
A
probability
prime
that
number.
at least one. So, okay, the following events, a prime number. Yeah, you can say that. Hello?
2, 3, and 5.
Yeah,
So 1 by 2.
1 by 2. So this is for
The second one is a number greater than or equal to 3 will appear. That will be 4 by 6, which is 2 by 3.
yeah. So third,
Then third one, a number less than or equal to 1. Only 1 by 6.
yeah.
And
Fourth,
fourth one, a number more than 6, that is null set. 0 input. Then fifth one, a number less than 6. Will appear 5 by 6.
question number 5.
So coin with one mark on one face, 6 on the other, and die are both tossed. Find the probability that the sum of numbers that turn up is 3 and 12.
See, in this case, the die is having two faces, okay? Like this.
Coin, no, sir.
Oh, sorry, it's a coin. One side it is 1 and the other side it is 6, okay?
Understood, sir. Um, for the first one, sum should be 3. Um, 1 comma 2, and that's it.
Fair coin with 1 marked on one face and 6 on the other, and a fair die are both tossed, okay? And then a die is thrown. So what is the probability of getting uh, 12? So if the first one is 1, the second, the probability of getting 3 is, the second, in case it should be 2, so that 1 plus 2 is 3, and and there is no other chance. Okay, and the
Yes, sir.
12 it is, so the probability is what?
1 by uh, uh,
What?
1 by 12.
Yeah, 1 by 12, because the sample space containing 12 elements. So in the second case, if it is 1, there is no, I mean, if it more, the
1 by 12 only.
1 by 12, because the maximum is 6, so you'll get 7. So that is not equal to 12. And if you take 6, 6 comma 6 is 12. Again, it is 1 by 12. Yeah, that's right. So question number 7.
Minutes, sir.
If a coin is tossed 4 times, okay, a coin is tossed 4 times. So the total number of outcomes are 16. And and a person with win rupees 1 for each head and lose 1.5 for each tail.
For each.
Okay, like for tail you will lose 1.5 rupees, and for head you will gain 1 rupee. So for the sample space, calculate how many different amounts of money you can have after 4 tosses. Probability of having each of these amounts. Okay, yeah, there will be 16 things. Okay,
Yes, sir.
so you have to find all the all the things. So how much amount do you have? For example, just go for tree diagram. Okay, that will be much easier. Like in the first case, you'll get either head or tail, right? So
Yes, sir.
is nothing but plus 1, and tail is nothing but minus 1.5. Okay, you are losing. Okay, when you get a tail. So if you get head, again you'll get either head or tail in the second chance. Same as here. Again you'll get head tail. 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 Again, this fourth chance you'll get head tail, tail, head tail. Okay. You'll get almost 16. Okay, right? So 16 things. So if you take all
All if all heads are there, then it will be 4. We
four,
will get
here
4.
rupees, and what is the probability?
4 by 16.
No, no, probability is 1 by 16. Okay, getting all heads is only one. Okay,
Yes, sir.
that's one thing. So that is 1 by 16. And in the second case, head, tail. Okay, you go for head, tail. So plus 3 minus 1.5, that is 1.5. Okay, right? Again 1 by
Mm,
16. So each, I mean, the probability of each event is equal. That is always 1 by 16, right? Because we are taking only one event, I mean, one thing at once. So it is 1 by 16 for all the case. And you will get, like, according to the things, you will get either 1.5 or 4 according to your head tail, like that. Okay, you can count it. This is how you do it. You will get 16 outcomes, I mean 16 things. Sometimes they are repeated, but you will get 16 things, right? It will take time, you know how to do it. Question number 9. If 2 by 11 is the probability of an event, what is the probability of the event not A? Yeah, very good question. Not A means what I said. Not A means it will contain all the events except A. All the events of the sample space A, right? So I can write,
that will 9 by 11.
yeah, 9 by 11, very good. So that is nothing but probability of A complement is nothing but it contains all the events of the sample space except A, or probability of sample space minus probability of A. Probability of sample space is always 1, minus A is 2 by 11, so it is 9 by 11. Very good. question number 11. A lot of questions. In a lottery, a person chooses 6 different natural numbers at random from 1 to 20. Okay. So, and if these 6 numbers match with the 6 numbers already fixed by a lottery committee, he wins the prize. Okay. So, what is the probability of winning the game? Order of number is not important. Okay. So forget about the order. Once you have taken like 1, 2, 3, forget about 3, 2, 1 or 2, 3, 1. Okay. Order is not important. Once you have taken 1, 2, 3, that's it. You don't have to repeat that again. Okay. So 6 different natural numbers at random. I think mm, I think 1 to 20. So there are how many numbers? It is 20 minus 1. 20 numbers. 20 numbers. So each time you take 6. So 6, 6, 6. So if I have taken, first I will take 6, then I will take these 6. That's how many times I can take till I reach 20. This till 15. So I think there are 15 chances. 15 times I can take different natural numbers, and the probability is 15 by total numbers are 20. So this is the probability. So I'm telling first, I mean, I'm taking in order like without, I mean, random, not the order is important. So I take 1 to 6 because 6 natural numbers means first I have taken 1 to 6 and next time I have taken 2 to 7 like that, 3 to 8, 4 to 9 like that. So the last one is 15 to 20, right? 6 numbers. So there are 15 times I can take these set of numbers, right?
Yes, sir.
15 times I can take the set of 6 natural numbers randomly from 1 to 20, and the order is not important. So 15 is the possible outcome and 20 is the total number of outcomes, or all the outcomes in the sample space. Okay. Yeah, that's a tricky
Okay.
question. And question number 13, fill in the blanks in the following table. Okay. So what is probability of A union B for part 1?
Oh, they told. Um.
Okay. I think this is the ending. Yeah. I will finish it. Yeah, probability of A union B.
7. 7 by. No, no.
I mean, just tell me how you do it. I mean, I don't want the answer. You can simply tell me how you do it.
Oh, union meaning we need to find the.
Yeah, probability of A union B is nothing but probability of A,
8 by 50.
probability of B minus probability of A intersection B. Okay. So basically, A means, see, if there is a thing like this is the A and this is B. For suppose if I have taken red color, so individually probability of A is nothing but this, right?
Yes, sir.
So now I will take another color. Individually probability of B is nothing but,
7 by 15, sir.
yeah, I mean, forget about the answer. You can get the answer by looking at the formula, but you should know why we are taking minus intersection B again. Okay. And there is a common thing here, right? Which contains both red and blue. Okay. So what I said, A union B is nothing but it contains all the elements of A and B, but not repeated. Okay. Here This thing is repeated again when you are adding individually A and B, right? That's why we are subtracting one intersection part so that it is not repeated again. Okay.
Yes.
Here the intersection part is we are adding twice. While adding A and B, you are adding this thing twice. So that's why I'm reducing one thing, subtracting that intersection part. Okay. So that
Okay.
probability is probability of individual event A, probability of individual event B, is probability of intersection B. So you will get some answer. Okay, 1 by 3 plus 1 by 5 minus 1 by 15. And what about this one? Second one?
B intersection. Oh, sorry, A intersection. Third one, no, sir?
Second one. You have to fill this blank. So what will come here so that this will be satisfied?
Zero point 6. 1 minute, sir. Z- uh, 0.5.
Yeah, 0.5 is the answer. Similarly, you can do the third one. So what is question number 15? If E and F are events such that probability of E is 1 by 4, probability of F is 1 by 2, probability of E and F is 1 by 8. Okay? E and F means E intersection F. Okay? If they say and, then it means intersection F. If they say or means that is union. Okay? Remember that. Find the probability of E or F. Okay? E or F means you have to find the union. Probability of E union F. Can you find that?
Yes, sir. B, B, mm, 5 by 8, sir.
5 by 8. This is nothing but P of E plus P of F minus P of intersection. Simple. So here, this is a good question. Second one is probability of not E and not F. Okay, probability of not E means E complement intersection F complement. Okay, and means intersection. How to find?
Yes. Mm.
So first thing
Second.
before doing this, there is a property like E union F or E complement intersection F complement is simply union F whole complement. Okay, and E complement union F complement is E intersection F whole complement. So if you know this property, you can answer this easily. So E complement intersection F complement is probability of E union F whole complement. Okay, that is you know what is E union F. So not E union F. Okay, so you got E union F as 5. Okay, not E union F is 1 minus 5 by 8, right? Sample
Yes, sir.
is 1, 1 minus 5 by 8 is 3 by 8. So the answer is 3 by 8. Yeah, you should know these properties. Otherwise, you cannot answer. So you can note it down. E complement intersection F complement is not
Are
F.
you recording this?
Yeah, I'm recording. Yeah, I'm recording this. Yeah, I can share you that one.
Yes.
So question number 17. So A and B are events such that probability of A is 0.42, probability of B is 0.48, probability of A intersection B is 0.16. Find probability of not A. Can you find that? Probability of not A.
Yes. Mm.
What is probability of
It's 0.58.
yeah 0.58? What is probability of not B?
0.48.
0.
No. Sorry, by mistake I said that. 0.52.
0.52. And probability of A or B?
0.74.
0.
74.
Yeah. So that's right. So question number 19. So in an entrance that is graded on the basis of 2 examinations, the probability of randomly chosen student passing the first examination. Okay? Probability of passing the first examination is 0.8, and the probability of passing second. Probability of passing second is 0.7. The probability of passing at least one of them is 0.95. At least one of them means what is probability of passing? Both means probability of A is passing, intersection B is passing. Okay, both of them passing means it is the intersection they are asking. But what they have at least
Yes, sir. There,
them,
probability of A and B.
yeah, this is probability of A passing. This is probability of B passing. So they are they are asking A the intersection B, and they gave you at least one of them passing means either A is passing or B is passing. Okay, that is nothing but they gave you
0.8 plus 0.7 minus 0.95.
uh-huh. So that will give you
0.55.
5. Yeah, that's the answer. Question number 21. So in a class of 60 students, 30 opted for NCC, 32 opted for NSS, 24 opted for both NCC and NSS means this is intersection. Okay, and means intersection. So if one of the students is selected at random, find the students opted for NCC or NSS.
Yes, sir.
Yeah, you have to find the probability that the student opted for NCC or NSS.
Okay. So, both NCC and just 1 minute.
Yeah, all you need to do is you have to add 30 plus 32 minus 24, right? That should be divided by total number of students, 60,
Yes, sir.
right? So the sample space
19 by 30.
19 by 30. Yeah. So the student has opted neither NCC nor NSS. Okay, this is nothing but probability of if A is NCC, then probability of A complement union nor means or nor B complement. Okay, just like or there is a nor. Nor means not I mean B complement. Okay, so this is nothing but P of A intersection B whole complement means probability of not A and B. Okay, not choosing A and B,
Yes, sir.
not A. So what is the probability?
11 by 30, sir.
No, not A and B is simply 60 minus A intersection B, right? Not A and B means probability of sample space minus probability of A intersection, right? So sample space is like 60, which is 1. 60 by 60 is 1. I mean 60 by 60 minus 24 by 60. So 60 minus 24 is 36 divided by 60. So that is 6 by 10, which is 3 by 5. Did you understand that?
Yes, sir.
The student has opted NSS but not NCC. That means probability of NSS, suppose it is B, NSS but not NCC. So B intersection or A complement. Okay, B intersection A complement. Is kind of opted for B but not NCC. So B intersection or else B of B. So it is B union A complement. Okay? B union A complement. Sorry, B union A complement. Okay. So that is, I think this should be done in case of Venn diagram. So suppose this is NCC and uh, this is what your NSS. So what they said, there are total 60 students. Total NCC and NSS will contain 60 students, including the intersection. So first you write the intersection part. So that is 24. So that only NCC part will be only this one. Only NSS part will be this one. Okay. So because all the NCC guys are 30, so 30 minus 24, 6 is only opted for NCC. Okay, and 24 is intersection of both, and only for NSS, 32 minus 24, that is 8. So only NSS is 8. Okay? So that means the students has opted NSS but not NCCs. NSS but not NCCs, only this part. Okay, so that is 8 divided by 60, right?
Yes, sir.
You have to understand this Venn diagram. Once you understand, you can use it. I think I finished this probably. You try to do the homework questions like all the even numbers. Okay, from next maths class onwards, I will go for this Telangana State Board Intermediate textbook. Okay. So in that, whatever we didn't discuss, I will discuss those topics from each chapter, and then we will solve some questions, and then we day by day. Okay.
Okay, sir.
Yeah. I think they covered a little bit more in Telangana State Intermediate Board, so that we will cover like we go for like trigonometry. Whatever we know, we can discuss. I will discuss only like what are the like new things in that trigonometry, or the extra things that is added in the Telangana State Board, and then we go for questions. Okay.
Okay, sir.
Yeah. So you are writing for Telangana.